Welcome back to DellyMaths Concepts. If you're in search of any CXC class, well, now is the time to join. Here's my number, 4818561. You put that 876 here if you're somewhere outside of Jamaica. Let us take a look at this um, questions. So question one says negative 3 square plus negative 2 square. So let us just quickly work that out. Anything squared is always positive. Negative 3 square will give us positive 9. We're adding that to negative 2, which is squared, and this is going to give us 4. 9 plus 4 is 13. So our answer is C. Remember, anything squared is positive. Now let's take a look at the second one. What percentage of 40 is 8? Now the of is your denominator all the time. The is your numerator all the time. So the is goes at the top, the of goes at the bottom, right? So that is how we put that together. So what percentage? Well, we turn this into a percent. We multiply this by 100. Okay, so we could do whatever we want. We could cancel 10 into the 110, 10 into the 44, and then 4 into itself 1, 4 into 8, 2, 2 times 10, and we're getting 20% for number 2. Quite easy, right? Now, number 3 says when 0.45 is written as a common fraction in its simplest form, the result is what? Now, what we're going to do is to take our 0.45 and turn it into one of those decimal fractions. So basically, this is the same thing as 45 over 100. Well, you could know by looking at the number of digits behind the decimal place. And as you could see right here, we have 2 digits behind the decimal place, which would have meant that we need a 2-0, all right, with a 1. So it's a decimal fraction, and all decimal fractions, the denominator starts with a 1 and then zeros after that. So in this case, we have 45 over 100. Now, what we want to do is to cancel this down as best as possible. So whichever way work for you, it does not matter. Let us say we're using 5. 5 into 45, that's going to give us 9 times. And 5 into this is going to give us 20. And if you look and 9 over 20 cannot be broken down anymore, then that's where we stop here, since we can't reduce 9 and 20 any further. So there it is. We go with that. Let us take a look at number 4. So number 4 says 235 times 48.7 is equal to, this is 11,444.5. Then 2.35 times 4.87 is what? Now, as you could see, we're not going to multiply this because you could see that all the digits are very similar. So which means that we're focusing on the digits. There are two things you could do. One, you could focus on the digits that come after the decimal place. For example, we're looking for an answer with 4 decimal places because we have 2 decimal places here and another 2 here. That means I must see an answer with 4 decimal places. And this would have been the suitable response for that. Another thing that you could look at is your approximation skill. For example, this is almost 5, right? So this is like almost 5 times a little bit over 2. So 5 2 is 10. My answer has to be a little bit over that. So 11.4 really would have made it again. So if you want to approximate based on the ideas, or if you want to look at the decimal point and the digits after that, then suit yourself. But remember, though, you want to make sure you're taking context the value of the numbers that you were working with. Now let's take a look at number 5. It says a test was marked out of 80. A boy scored 60% of the mark on the test. How many marks did he get? So what we're looking at is what he actually scored. Whatever he scored was actually 60% of the total. So basically, we're going to represent our 60% 60 over 100 times the total. So we're finding that of it. And from here, we could cancel. For example, this 0, you could divide by 10 here, and then we could take this 0 off again. So we're left with 6 times 8, which is 48, okay? So that's one of the methods you could use, all right? So another method that you could have used, and this is totally up to you, is that if we have 80, 10% of 80 is to take off the 0 at the back. So 10% is equivalent to 8 marks. And then 60% means that you're multiplying 10 by 6, right? Which means that if you multiply the 8 by 6, you will get the equivalent idea, which is 48. So there are various ways that we can approach these problems. You work the method that suits you best. Now let's take a look at the other question right here. The other question says, Dan sold 40 concert tickets in 5 days. So a total of 40 tickets were sold in 5 days. Each day he sold 3 tickets more than the previous day. What is the ratio of the number of tickets sold on day 3 to the number of tickets sold on day 5? So what we want to do here is to set up a system. Let us find what X is, all right, or find that unknown. So I'm going to set up a system and I'm going to be using X as my unknown, and then let's see. Now, remember though, I'm going to call day 1. So I'm going to have day 1, day 2, there is a day 3, there is a day 4, and there is a day 5. So basically, if I say that we sold X tickets on day 1, because each day we're selling 3 more, it means that day 2 will be selling X plus 3. On day 3, I'm going to be selling X plus 6, which is 3 more added to 3. Then it's going to be X plus 9. The last day, X plus 12. Now, remember, we were told that the total number of tickets sold over the 5 days was 40. So I am going to add these. So if I add these 5 days, it results in 40 tickets that were sold. So basically, I'm solving just a regular algebraic equation where I'm going to put together my x's. So I'm going to have 1, 2, 3, 4, 5 x's. So I have 5x plus, and I'll be adding these numbers. 3 plus 6, that's 9, plus 9, that's 18, plus 12, that's 30. We have 30 there. So 5x plus 30 is equal to 40. Then let us subtract 30 from both sides. So what we really have is 5x, this becomes 0, and this is equal to 10. We could see here that x is equal to 2. Dividing both sides by 5, x is definitely 2, right? So because we know that x is 2, I'm now able to compare day 3 and day 5. Let us take a look at day 3. So day 3, we add x plus 6. So this is day 3. And so x is 2, so this is equal to 8. And then on day 5, we had x plus 12. So that's going to be 2 plus 12, and that's going to give us 14. Now we're going to compare day 3. Remember, day 3 came first, so it's going to be 8 to 14. And then looking at this, that's not there. So you want to cancel down. Let's divide everything by 2. 2 into 8, that's 4. And 2 into 14, that's 7. So I'm looking for 4 to 7, and it's right here. It is very important that you look at how the question was phrased. It says, we want to know the ratio of the tickets sold on day 3. So day 3 must be first, which is the 8, which turns into 4. So pay attention to that, right? Let's take a look at the 7th question. Question 7 says, so we're right here. It says, which of the following sets is defined by, so we're looking at these numbers are a set of integers, that's for integer, where x is greater than or equal to -2, but less than or equal to 4. So basically, typically, if I go on my number line and I'm going to list all my integers all the way up to 4, 1, 2, 3, 4, -1, -2. If you take a look at this, we're moving from right here to right here, right on the number line. So those are all the integers right there, and we have an equal sign here. So we want to pay attention to that as well. So we're looking at D because D would have been from -2 all the way up to +4. And that's what this really refers to right there. Let's take a look at number 8. Number 8 says the set of positive integer that is divisible by 6 is an example of what? Now, what this is referring to in a nutshell is actually multiples of 6. So if you think about multiples of 6, because it did say those numbers, they are divisible by 6, which means 6 could go into them. And that means we're dealing with multiples of 6, which would have been an infinite set because multiples of 6 will go on to infinity. So it's an infinite set. Number 9, if the number of elements in the universal set is 25, right? And we're said we got here where the number of elements in A is 14, number in B is 15, and the union of A and B is 23, the union of the intersection of A and B is actually what? So they're asking, let's look at this. So number 9, if the number of elements in the universal set is 25, the number of elements in A is 14, the number of elements in B is 15, and the number of elements in A union B is 23, then the number of elements in A intersect B is what? There is a general formula that we use, and it states this. Could look at it like this. So I'm going to use A and B. So if the number, we could look at the number of elements in A intersect B is going to equal to the number of elements in A plus the number of elements in B. And we're going to subtract the number of elements in A union B. So basically, this is a general idea that we can use to solve problems that looks like this. So basically, we are asked to find this. So let us substitute what we have. A is 14, nominating B, we got 15, and then the union is 23. We're subtracting that. So we're talking about 29 minus 23, and this result is actually 6. So we're looking at 6 right here in terms of the number of elements that are actually sharing, they're intersecting A and B in both sets. Thank you. Now let us look at this other set question here. It says here, question 10 and 11 refers to the following Venn diagram, all right, which shows a universal set U and two sets T and C that represents the students in the class who plays tennis and chess. So we're looking at what we call a subset there, tennis and chess. So everybody in chess is a part of tennis, but not everybody in tennis is a part of chess. So we got to pay attention to that. Let's take a look at the question. It says, how many students play both? Now, the fact that chess is a subset of tennis, the moment you're in chess, you're automatically a tennis player that plays chess. So in that case, we have Paul and Rema, and so that would have been a total of 2. All right, so we have 2 persons that play both games right there. Let's take a look at our last question for now. It says, how many students plays exactly 1? So if you play exactly 1, we're looking for you on the outside of chess. So you're going to be in the tennis circle, but outside of chess. So we have Ali, Alex, Form, and Kayla. And those would have been 4. So we're looking for 4 that would have only played 1. Now let's take a look at this. Here it is. There we go. Thank you for watching DellyMaths Concepts, and look out tomorrow when we're going to be looking at another video like this. Like, share, drop a comment, and definitely subscribe to the channel. And if you're looking for a CXC class, here's the number, 876-481-8561. See you.